awesome people. How's it going? I know y'all were enjoying Amy's stream a lot. No worries, it was totally worth it. I was having so much fun watching you all guess. I was pretty confused about the spelling of omelette as well for quite some time. Hi Aryan, welcome back to the stream. I do too. I love how that's the maximum participation I see. Like people are interactive in the chat, but in the actual thing, that's the maximum participation I see. So sketch was amazing, guess. Anywho, folks, how's it going? How's second day of streams been for y'all? I know Amy was very popular a few minutes ago. That's a great question. I wish I could live in a garage, but no, this is what I've made my room into. Is it? Is it? I actually cleaned. Can you believe that? It's looking messier, but I actually cleaned it. Thank you, Amy. Yes, I'll be talking more about it if we ever end up in a hackathon together soon. Oh, I'm glad you could make it today. And if you missed the first one, is it a decent time for you to join? Please don't compromise on your sleep. Hi, Tintin. We're just getting started. The today's plan is to basically cover up what we couldn't cover yesterday. So we'll quickly go with the PPT very quickly, and then we'll dive into our simulators again. Not yet, but that's the thing. That's the reason why it looks so different. I was on it, and I actually did something really weird. But I drilled a flat glass and cut out this thing. It looks better in the light. I don't know if you can see it, but yeah, I'll be adding these circles to the rim soon. So let's see how that goes. Hey, Avirappa, Arivappa, welcome to the stream. Alright, folks, tell me, how's your day two been? What was your favorite stream till now? You know what? There isn't, and I completely forgot to ask Mary. Although it was a holiday for her yesterday, so I'll definitely ask her today when she comes on time. Thank you so much for reminding, Tintin. Yeah, I've heard Kev is very popular in his streams. I'm glad you all enjoyed Python. You know what? I honestly don't know if I have 20 resistor values or not. I have so many different kinds of resistors though all over the place. I actually got one of my working, so I have these trays where I keep most of the things that I'm working with, which ends up piling up over time, and then I end up, segregating it. So it's right now in the piled up stage. So we'll just go through some things that are there. Hi there, Rajan. Oh, is it so? I am so honored to be your first stream of day two. Oh, you want me to revise ADC? We'll do that. Don't worry. We'll do the revision of ADC. Thank you, Arabapa. Thank you, Praful. Welcome back, Kunal. Alright, folks. So, since y'all are still, I feel, kind of recovering from the fun mode and going into a, technical mode, I'm going to share the PPT. Let's quickly go over everything. Whatever we haven't gone over, we'll start with that. Alright, and then we'll spend a lot of time with simulators, writing simple code, understanding the structure of the code. I know one of y'all could make your LED blink yesterday. Everyone will get their LED to blink today. No worries, random person. Let me know if you have any feedback later or if you have any questions. I'll be happy to clear them up for you. Thank you, Shamari. I do like to see it grow, yes. Hi, Subroto. So we'll be kind of going over very quickly about what we did yesterday, just covering what we couldn't cover because there was a little bit of a technical, more like theoretical part which we didn't discuss. It's more of a discussion. We'll just do that. Alright, folks, awesome. Let me quickly pull up the PPT for us. In case you all are joining us for the first time, this is IoT, something what we call a meta track. I don't know if we're using that word anymore, the meta track, but it's basically a track. It's like a multi-part series where you kind of in the end make something big. And this is IoT, Internet of Things, where we learn a little bit of RTOS, we learn a little bit of embedded systems, we learn a little bit of electronics, and then we put it together to make one single IoT system. Oh, how to submit the proposal and notification. So you submit it on DevPost is what I remember. Let me quickly pull up DevPost for y'all. So devpost.com. That's a great question, Tintin. Is anyone else confused about how to submit their daily challenges? Uh, we can do. Thank you so much, Virat. I'm glad you enjoyed yesterday's session. Hi there, welcome back. And alright, I was showing their post. Alright, let me quickly share my screen. Present, share screen, window, Chrome tab. Tab, there you go. Alright, so this is the tab. Now I know that there's another URL also that you can use, which is I think ghw.mlh.io/daily challenge. Let me see if that URL works for me. ghw.mlh.io/daily challenge, and it doesn't, but challenges, today's challenge is elastic challenge. um, all right, this is probably not. All right, let's look at their post again. Their post, GHW, there we go. Week launch. This is I think the weekly one, and the daily, I don't think they have a daily one just yet. uh, So I think what's happening is they have single page where they'll be updating challenges every day. So you see prices, this is day one. And I don't think they have multiple days this time. So you need to go here and you can just keep submitting every day to the same hackathon basically. So you can keep adding projects for different track prices. Make sense? Tintin, does that answer your question? But just in case, let's see. Yep, there's no day one that I see for season launch. So yep, it's basically just this, and they'll update challenges every day. So I think they'll update day two challenges in a bit, and you all can just go. Or I think these are the day two challenges, the ones that are open. These that have been closed were day one challenges, and now tonight around 9:30 p.m. IST they'll close these challenges, and then they'll start the next challenges. Does that make sense, Tintin? This is the question I was answering for folks not sure what I'm talking about. Oh, is that so, Adi Snippet? Let me see if I can look for the form. Okay, there's a form. I think you'll get the form once you register. If not, let me register. And this is not where I want to register from. Let me register and see if I can get that form link for you all out as well. In case you are not sure, this is the link to start registering. Oh, perfect. You put it in the chat. Oh, there we go. This is the hack pack. My bad. It's not GHW, it's the hack pack link. I'm a little rusty. I haven't taken GHW in the past 2 months, but thank you so much, Shamari. There we go. I am again not sure, but I can definitely look into it if one of your fellow hackers does not have an answer. This is a good question, Virat. I think it's there on. It used to be there on the GHW website. I think they've taken down a lot of links. Uh, this is a great answer. Thank you so much, Krish. Alright, folks, thank you so much for helping each other. What I will do is I'll go over the website again because it's obviously not the same as when I did the last time. So I'll just revise myself and I'll have better answers for you tomorrow. Thank you again, Shimari. There you go. This is a great link to find. So I was on this page, but I couldn't find a very obvious link. But I will look it up, and if I do find it, I'll just we'll go over the entire thing tomorrow. But until then, I'm sure your fellow hackers have better ideas since they're submitting to it every day. And oh, is that it? Is that it? Let me see if I can show that to you again. Shared. Let's go to challenges. Learn more. Well, this took me to new. These are all taking me to new tabs, so I'm not sure. Okay, there we go. I think this might be different. Uh-uh. Yeah, I don't know. For me, when I click on the tab, it takes me to. Oh, now I see what you mean. So what's happening is some of the cards take you to GitHub pages, and those pages are the ones that I think you need to put it into the form when they take you to a new link. If they're taking you to DevPost, then you submit it to DevPost. Got it. Thank you so much, Adi Snippet. Awesome. I think everyone's gotten their answers. If not, there's obviously GHW Daily where you can ask these questions again, but I will definitely find out for you all and keep them ready tomorrow. You're telling me the travel brochure one, click it. Okay, click. Okay. Oh, got it. It took me to a season launch day to form. Fair enough. Thank you so much. I understand now. It's opening in a new tab. That's why you all can't see it, but I get the point now. Awesome, folks. Let's go back to our PPT. If there's any more questions, keep them coming. I'll take a note of them if I can't answer, and I'll get back to you, or let someone from MLH, a full-time team, reply to you in Discord. Awesome. So let's go back to sharing screen. Let's go back to our PPT. Is there anyone who's joining us for the first time? If you don't want to identify yourself, I just assume there's at least one person here for the first time and just take you through some basics. I hope you all have checked into the link that I shared earlier. Let me see if I still have the link on my. There we go. No, that's not the link I wanted to share. That's not the link I want to share. Give me 1 second, folks. Let me share the right link for this track. There we go. Alright, so if you all are here for the first time, make sure that you all check in. You'll get some extra brownie points, and the more sessions you attend, the more swag you get. Thank you so much, Krish. I really appreciate that. Krish is one of our, regular hackers who's super, super helpful. And awesome. So I haven't shared my screen. Great job. So let's go with the PPT again. And so folks who couldn't join us last time, we did a question answer format where we answered these all questions. I'll do a quick introduction of myself again in case you all are here for the first time or missed out on my introduction yesterday. I still haven't added my name to the introduction slide, which I should today on a priority basis. But we answered the question, what's IoT? We did skip IoT versus IoT, so we'll cover that first. We did skip how do we learn basics electronics as well because we went on to simulators directly, right? But we did do a little bit of practice. We moved around Uno, we understood a little bit more about signals. Whatever y'all want, whatever y'all didn't understand or y'all want me to, kind of take you over it again, we'll do it. Okay? And then we'll dive into actually creating, then we'll finish circuits that we'll eventually use for our project for the IoT. Oh, sure. So we're using Tinkercad and we're using Wokwi. Alright. So this is the second link that you all will be using today, much later in the session, of course, not right away. But what you want to be using right now is Tinkercad. So let me quickly send that to you all. This. So you want to be first going to Tinkercad. Alright. So in case you all are just listening to me, catch others up to what we've been up to, you all can go to Tinkercad and start playing around. And the last circuit we built yesterday was an LED connected to an Uno R3, and then we wrote a one-liner code to blink rather turn on the LED. All right. Awesome. And then I do have my basket of electronics out for whoever asks me to showcase some of the boards. If we get time, if we get to it, we'll definitely do that. All right. Awesome. Let's move on. Folks, again, who do not know me, hi folks, I'm Ritvi. I have been a coach for almost 2 years now. I complete 2 years next month. And I love taking streams. I love talking about hardware and IoT. I identify as a maker, as my background very much suggests. I'm currently freelancing. I'm a DevRel freelancer. So, in case you're not aware what's DevRel, developer relations is this really, nice intersection of engineering and marketing. It falls more towards marketing than engineering, where I just, basically talk about everything I make. So, if I use the product, I talk about how I use the product. And yeah, you all know I'm here because I'm a coach. So, let's move on. And again, so this PPT theme might seem super bizarre, which I love about it. This is one of those Google recipes template I love using these days because it's just so fruity and so nice, especially if your city is under one of those heat waves going around. All right, so we are live, and we did an exercise yesterday about posting whatever you think is an IoT device, right? Krish has been kind enough to entirely enumerate the process of challenges. Thank you so much, Krish. I don't think I can pin it, but yeah, if you all want it again, I'm happy to share it again on chat. Alright, so we did an exercise where you all went around posting pictures of the devices in your house you think are IoT, which was awesome. You all did an amazing job identifying devices that could be IoT. And then we went on to discuss what's IoT. What was the definition of IoT? Anyone want to quickly remind everyone what was the one single line that was easy, that made it easy to say, okay, is this IoT? Is this not IoT? That's the full form of Internet of Things. But we covered this really simple definition, which said human independent communication, right? Then what we realized was, okay, human independent communication. What do you mean by human independent communication? It means that communication, which is basically a machine sends a request and it knows whether or not that request was completed when it receives an acknowledgement about what happened to that request, right? That is what is called IoT, right? An Internet of Things. That is a great answer, Kunal. Perfect. Oh, this is a question for you, Krish. To just give you a TLDR on that, basically points. Well, the points mean not much except for your, guild, which gets ranking based on the points. But really, the more sessions you attend, there's a quota. Let's say the first 5 sessions, you get some amount of swag, and then every 3 sessions you attend, you get more swag. It changes every GHW, sometimes marginally. I'd suggest you go to the opening ceremony and check what the exact quota is this time. All right, there we go. Thank you again, Krish. Awesome. So that's what we did. Remember from yesterday's discussion, we know that the acknowledgement part is super important in making sure it's actually a communication cycle and not just a signal. Basically, a remote sending out IR signals is a one-way thing. It doesn't know whether it reached the TV. It doesn't know whether the channel changed, whether the volume went up or down, right? So acknowledgement is important. This is a simple architecture. So if you all think I'm going very quickly, people who are joining us for the first time, we've already covered this. Okay, so if you want like a nice, slow, really long explanation, you can go back to yesterday's stream. Okay, today I'm just covering it so you all know what we've been through in case you all get confused later. All right, so we just looked at different architectures and hierarchy of IoT. So this is one way to look at it, where your server and the cloud is in the middle. What do you mean by server? What do you mean by cloud? If you have those questions, you can go back to yesterday's stream, or if you have, you need me to answer right now, I will do it. Okay, just let me know in the chat. Okay, that's one way to visualize it. You see here that you can visualize it like this. Also, remember, IoT can also be a very complicated pyramid network where you have like consider your smart home system, right? My room could be one entire thing of IoT, and then that could be connected over multiple levels. Make sense? Alright, so we haven't covered the slide entirely. We covered a little bit of what's RTOS. We do have to cover all the other, words, components, and sentences, and we'll go with them. Before that, though, I definitely want to cover IoT versus IoT. It's a short thing, and I'm sure you all would, learn it like basically in no time. If you all have any questions, though, regarding anything on screen right now, like on this slide, ask them. I'll either tell you whether I'm going to answer them once I come to the slide, or if I'm not, I wasn't planning on, I'll just answer them right away. All right. Okay, folks. IoT versus IoT. What do you think IIoT is? So, ethical core, we actually covered this entire PPT yesterday. There are a couple of slides we couldn't go through, which I'm covering today. So, everything that I just went over, you can go and look at yesterday's stream. And if you have any questions, you can reach out to me on any social media platforms. Today, we'll do this, and then we'll actually start writing code for our own IoT projects. Make sense? Yes, that's a great answer. Internet of Things. Well, I wish it was that uh, complicated, really, but it isn't. It's actually much simpler. Yes, Shumari knows the answer. It's Industrial Internet of Things. I love talking about Industrial Internet of Things. You'll know why in just a minute. Why do you think Industrial Internet of Things is different than Internet of Things? No worries, ethical code. In case you don't understand anything and you're definitely following along, just stop me. I'll explain whatever you need to, okay? Interactive IoT. I like this. I wish this was the definition also, Roshan. Also, welcome back to the stream. Industrial IoT. Perfect article, God. That is exactly what it is. I don't understand. Did I miss a question here? Oh, you're talking about this. My bad, my bad. Alright, y'all can continue your discussion. It is not, so industry 4.0 is more about how industry is more skill related than it is product related. That's vaguely related, I guess. Good, I love the overall 360-degree thought process, but I appreciate this answer. No, it isn't an institute at all. All right, folks, so now we know that it is. Hi, Self Roster. I'm seeing you in a stream after a really long time. To be fair, I'm taking a stream after a really long time, but oh, I know, Krish. I know you know better. That is correct. But why does industry need? That's a great point, Adi Snippet. Like, okay, so industry purpose, if that's how it's different from IoT, what is the industry need that is different from your regular need, right? I mean, the device is doing basically the same thing, right? It's sending stuff over the internet. What is it that makes the industrial use, or how is the industrial use so different that there's an entire section of services dedicated to IIoT? Uh, Oh, you want me to cover stuff from your starter kit? Why don't you send me the starter kit specification, and I'm always happy to, show you all how you can get started with whatever kits you have. It is very simple. It's amazing because that way you'll actually see different architectures, and I would love for you all to share what you all are making with the different kits that you all have. Yes, but what do you mean by industrial aspect? Okay, that is a good thought. Automation is important in the industries. Again, great direction of thought. That is also, so yes, there'll be a huge component or in an IoT where a lot of things depend on the data being processed, right? So the data that you're getting is important, right? Yes, there are a lot of humans at risk and the machines are big. So if you put everything onto an IoT, you need to make sure that there's quick action and response, right? Great answer, yours, as usual. Super proud of y'all, and I miss y'all not coming up with funny analogies, but Great answer. Let's remember yesterday we discussed, Aryan, how that robot arm, that robot hand, is basically a device which has a capability to be an IoT device. But whether or not it is an IoT device will depend on the system you're looking at. Fair? Okay. So why is IoT so different? IoT is different because remember yesterday we spoke about hard RTOS and soft RTOS, right? In hard RTOS, everything is very accurate, right? 2 seconds means 2 seconds. If you give a command, the command is going to go through till the end. There's no, oh, I maybe didn't listen to the command, right? I do not know about this, but I why don't you go ahead and send the link in the Discord channel? That is an amazing answer, Roshan. Industry aspects more focus on size, performance, and efficiency. Yes. That's a great way to look at it, Ranjan. But I'm just going to tell you how it would differ on an industrial level. Okay, imagine this, right? You have one home. You have a very smart home. Everything works in IoT. Now you also own a factory. Okay, the factory does a very simple task. Okay, but it does that on a really big scale. So take something very simple, right? Like cutting cloths. Okay, so there's a factory line. You have a machine that cuts cloths, and then you have factory workers who allocate or take and do one manual function on the cloth and pass it on to the next machine. It's a very simple assembly line and there's not much to it, but you want to add some automation to it. All right, what are your constraints? One, they're really huge machines, right? You cannot have them be out of control even for like a minute, because it's doing a lot of work very fast. So even if you lose a minute here and there, forget minute, a few seconds, you end up losing a lot of material, electricity, clock, because it's a huge scale, right, that you're working on. That's one thing, right? Second thing is, the machine itself is super precise, right? You don't really need to control the precision of the machine. What you do want to control is maybe safety of the people. What angle is it at? If someone's trying to put a hand, you want it to stop immediately, right? Those are the things you can add IoT for. Maybe not if you have a sensor, right? So think on those lines and then maybe tell me where you think IIoT will be different from IoT. Oh, sure, Zelfroster. So while I'm not very qualified to tell you how to, be successful in this career, I can always tell you how I got started and where I'm at, right? But if you're really like, I know someone asked this question yesterday as well, and I've mentioned this. If enough of you all really want this, I can definitely get someone, way senior in the IoT industry, and then we can have a talk with them and, make an interview format, and you all can ask all these questions, right? Uh, Alright, folks, I'm gonna make it very simple for you. Remember, I told you you have a very smart home when I gave you that example. It doesn't matter if things don't work on time at home, right? You can have like complicated systems at home of IoT, but if they don't fire at the right time, it doesn't really make much of a difference. Okay, fine, the microwave didn't fire at the right time. The bulb turned on 5 seconds late. It didn't turn on at all, so you had to, give the command again. The AC was at the wrong temperature. It didn't switch temperatures at the right time. No one's really getting affected too much, right? Until and unless like the thing itself does not fall, which IoT is not responsible for in the first place. It's safe. It's no one's getting affected. In an industry, however, if you have too much of a complicated system, right, things can go wrong very quickly and like really wrong very quickly. So industrial IoT counterintuitively is much simpler than your regular IoT, right? The sensors are minimal. The action trigger communication cycles are very minimal. You want things to happen accurately and efficiently, not on a okay, this can fire too. Oh, let's fire this as well, and let's make this move also. Make sense, everyone? Precisely, like things can go wrong on so many levels on an industry thing if you just try to make it complicated. And when I say that, I don't not saying that there aren't complicated systems out there. I'm sure people are working on some real cutting edge technology and doing it. But ideally, let's say you come, a factory person comes to you and is like, okay, I want you to solve this problem. You will solve only that problem. Unlike at the house, if someone comes and you're like, okay, can we get a smart bulb? And you end up getting smart everything and no one really cares, right? Makes sense, folks? How is that IoT? It can be IoT. How do you mean it's IoT? Guru, do you see the difference now? And this is just one of the difference, right? When you start looking at industrial IoT, there's a lot of things that are very, like different to accommodate for better efficiency, for lesser costs. Remember, anything you're putting in an industry level, even if it's like, first you want it to be simple so that it's absolutely efficient, accurate and precise, right? Second reason you want to do that is, even tiny device, if you're scaling it at an industrial level, at a factory level, a small factory level even, you're spending a lot just setting up that small system, right? Every sensor, every microcontroller, remember, you're going to have that many network, points for everyone to communicate and everyone to get access to the cloud. So it's simple things like those that make industrial IoT very different. Now, why did I spend so much time talking about this? Testing, yes, those are all great examples. But you all understand, I'm not talking about a specific machine or a specific, use case. I'm talking more in a, why do you not have IoT things here, and why is there IoT out there? Boards, right? The boards that you use. Uno R3 is something you can use for automating whatever you want in the house. You'd never use that in a factory. What you use in a factory is something slightly more, sophisticated, that can, for example, we discussed ADC yesterday, right? We know that our board has a 10-bit ADC. For an industrial level, even for a simple IoT machine, you want to make sure it's absolutely precise, especially if it's a temperature, function of temperature, right? So you're going to get a much more sophisticated board with at least a 16-bit or 24-bit ADC, and make sure that very precisely measures what the change in temperature is. And the more sophisticated your board goes, the more costly it gets, right? And cost is a huge factor when you're trying to do anything on an industrial level. Okay, so why did I spend so much time on this? This was a simple thing, right? Why do I spend? The reason I spend so much time on this at every stream when I take about when it comes to IoT or electronics is because eventually, when you're participating in hackathons, or you all are here because you all are problem solvers and really good problem solvers, right? I want you all to be really conscious about the problems, the solutions that you're suggesting to the problems, right? You all try and solve for the most amazing problems every weekend. I judge the hackathon, right? Some of you all are trying to target mental health. Some of you all are solving for the hospitals to become more efficient, to be able to identify, okay, maybe being fancy is not a priority for this industry, or not a priority for this particular situation, or if you're solving for something simple at home, you can make it as bizarre as you want, so that you all have more, a more 360-degree approach to solving a problem. Make sense, everyone? And the reason I stress on this more is because we'll be doing an exercise, hopefully in today's session, if not today, tomorrow, where we'll actually break down a problem, right? And we'll see, okay, is power my priority here? Why would power be a priority? If you're making an IoT device, let's say you're making a wearable IoT device, you cannot tell the person, okay, this will measure your pulse, this will tell you the speed at which you're walking, this will even give you, your location down to the last centimeter. You just have to charge it every 5 minutes. They'd rather have a watch that gives them a 3-meter accuracy, but that goes for a few days at the very least, right? So in that, when you choose your board, when you choose your sensors, when you choose your entire product, you're gonna go for something that is more power efficient, but maybe a little less accurate, right? Makes sense. But if it's a medical device, right, then it doesn't matter if you can keep it plugged in, but it needs to be super accurate. Make sense, folks? I like the idea, Krish. It's tad bit non-constructive, but that's okay. All right, folks, are we on the same page about IoT versus IoT? And it's more of a thought approach than really, okay, what does industrial IoT really mean? It's about prioritizing your design components to suit the situation in the best way. Precisely, Roshan. I couldn't have put it better, right? Make a small product. Make a product that does just one thing, but does it so well, which is why you need to understand what the situation is, right? Awesome. Let's move on. So, okay, but why we just covered that? Perfect. This is another thing that's a huge point that I love to give in this stream. Is just because it works doesn't mean it's the solution. Okay? Iterate, think through it, alright? Shimari, I cannot access this link. You know what? I actually have my Twitch open as well. Let me see if I can quickly open that link. Yeah, I have it open. I just go through it very quickly when we take a break, a 5 minute breather break, and I will get back to you with specifications and how you can get started. Okay, awesome, folks. That is it. That is all I really wanted to discuss with you. I think it's very important. I could be obsessing over it for things might be obvious to you, but I just think sometimes it feels good. These things can be mentioned, and it causes no one any harm, right? All right, let's move on. How do we learn a lot of electronics? But fast, right? Uh, of course, your Tinkercad is a great option to go about it, but the really, really nice way to go about it is to read textbooks. I know y'all would never want me to say that, but turns out, like for example, recently I've been doing a lot of reading. So when it comes to power electronics, or when I'm talking about, I know it's not your thing, and y'all are probably here for learning something extra. But if you do end up getting curious about components, about how a microcontroller works, it's really nice to go back to your university, look at the syllabus reference books, and just pick up the book and go over it. Don't you don't have to memorize it. You don't have to read it like, oh my god, I need to know everything. But just flip through it and see how much you can just absorb by that. No YouTube channels for you today, unfortunately. Okay, good, folks. So we are to the point where we were yesterday, where we got started with simulators. So let's go back to that. All right, folks. I want a quick count of how many of y'all could follow the circuit yesterday. If there are enough of y'all, I'll quickly show you the next steps and then do the thing again. And if there are a lot of people who are starting from scratch, we will start from scratch, and y'all can help your friends catch up. That's how I learned it, Divyansh. Especially now when I'm kind of revisiting things, especially every time I take a stream, I sit down and study a lot myself to make sure, I have a lot of information off the top of my head, and yet sometimes I end up searching with you all, right? I mean, there's only so much you can remember. So, I think one of my favorite things that I learned in college and, like properly used a book and enjoyed it was op amps. Op amps are a really cool thing to get started if you want to go through electronics. So, op amps and MOSFETs, amazing things to learn about if you all are, interested in IoT and want to continue it to some extent. Forget IoT, really, electronics. Alright, folks, how many of y'all completed the LED circuit yesterday? Quick heads up. Awesome, Kunal completed it. That's awesome, Kunal. Kunal, do you want to quickly post a picture of it in Discord while we wait for everyone else to answer? I will share the pictures. You all know where to post it in the season launch channel. I will quickly share the channel link. Copy link. Oh yeah. Don't worry, Shamari. I know you've been attending streams before, so it'll be easy for you to catch up. Oh, don't worry. We'll do the code one again. Okay, so I have a basic idea of where y'all are at now. That's all I really wanted. If anyone else feels like we're going too slowly, let me know. Okay, let me quickly add this to the stream. Perfect. And this is what we were at yesterday. Okay. What we've done is basically we've added a potentiometer and an LED, and what we're going to do is we're going to make the LED's brightness. We're going to control the LED's brightness with the potentiometer. Okay. Oh, awesome! You used multiple LEDs and you used resistor. That's great. That's awesome. All right, folks. Let's look at our socket right now. Okay, so what do we know here? This is an Uno R3. Remember, this black part is our microcontroller. This is our development kit, uh, which the Arduino people have been kind enough to design for us. They have given a digital pin to us, to which our LED is positive, which is the anode is connected, and our cathode is connected to the ground to complete the entire circle. Right now, the LED will only glow when I simulate it when my code asks it to blink, which is why I have in my code the void setup. The void setup is the part of the code that runs once, and the void loop is our RTOS part, which basically keeps running over and over again until stopped or until the power is removed. Alright. There's also a reset button usually on an Arduino, which also helps you. This is, I think, the reset button, which helps you kind of go over the setup code again. All right. We've made the pin mode as input. We haven't still read pin mode. Okay, so that's what we're going to be doing next. You declare your global variables here like you do in any other code. So I'm going to take integer a, or rather integer potentiometer equal. So I'm going to initialize it to 0. And then what I'm going to do is I'm going to do an analog read here. You can remove the delays, but they don't really make a difference over here. So I'm going to do an analog read. Remember what our remember what our controller does when you do an analog read. It's going to read the voltage in steps of 1024. So based on where the potentiometer is at, it's going to get a value between 0 and 1024. All right, so there we go. So I'm going to get another so my a variable, which is basically potentiometer meter, is equal to analog read. Our pin is A0. All right, folks. Cool. So now my potentiometer should have a value based on the variable potentiometer should have a value based on my wiper, right? So what I'm going to do is I'm going to quickly print it out, right? So I'm going to do a serial dot print line, and we're going to print out potentiometer. All right. Okay. All right, folks. This is it. This is really not necessary, so I'm going to get rid of this. And there we go. And now we're going to quickly start simulation. Okay, so this won't run. Anyone can tell me why this won't run? You see, there's nothing on the serial monitor. I really don't want to answer this just yet. Oh, yeah, absolutely. I'll post the code. So, what we do not have here is something called the baud rate. Okay, I'm going to explain baud rate in just a second, but how you give a baud rate is you do a serial dot begin. Where is it typing? Did it type? I thought it did. Okay. Now, so I'm going to type a serial. I think, oh, I need to stop simulation. My bad. To write again, you need to stop serial, just stop the simulation, and this won't be in loop. This will be a setup code because you give the baud rate only once, and it sticks to the baud rate. Okay, serial dot begin, and I'm going to give a 9600 baud rate. Now, let me explain to you very quickly what the baud rate is just after we start the simulation. Right, so now you can see that we're getting a value. Right now, every time I change this, the value will change. There we go. This should make it lesser. Right? So you see towards the ground, the value is 0. And as we, go towards the V in, rather the 3.3 volt, the value increases to 621. Now watch what happens when I move this 3.3 volt to 5 volt. Right, so I'm going to delete this, and now we're going to connect this to here. Now let's start the simulation. Right, so good code, serial monitor. See, it went to 1023. Right, because remember 5 volt divided by 5 1024 is, that is what is giving us 1023 value. Make sense? Oh yeah, sure. I am so sorry, folks. Let me quickly make this bigger for you all. Is this better, everyone? All at the same page? Can you all see? Okay, what is baud rate? Let's quickly have a discussion about baud rate before we understand how we map the value of the analog read to the brightness of the LED. Alright, awesome, right? So, what is baud rate? There is something called your bit rate, right? Which is basically your bits being sent per second. So, let's say a sensor is sending the value at 5 readings per minute. All right, so 5 readings per minute. But how fast is that one reading going? Right, your controller and the sensor sending it have to be sending and listening on the same cycle, right? So I could be telling y'all hello 5 times in 1 minute, right? Hello, 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 right? Now I did say hello, but how fast was that hello? Right? I could say it really quickly, like like hello, or I could say it really nice and slow, like hello, right? So how fast is that one reading is your baud rate? Does that make sense, everyone? There's something called the sensor rate, which is okay, I'll give you 5 readings in a minute, or 2 readings in 10 seconds. But how fast is that one reading being sent from one point to the other? They both need to match. So your baud rate is the rate at which the controller needs to listen for every bit to arrive. It's a ratio, which is why it does not have a unit. Make sense, everyone? Everyone on the same page? If you're not understanding, let me know. I'm happy to explain it to you. I know it gets weird and it gets really bizarre, but that way you're going to remember this irritating person telling hello so many times, right? You're going to be like, okay, we got it, just to stop. Don't say hello again. Uh, sure. Do you want, alright, folks. I didn't want you to repeat it again. I try and use another word this time. You just use the word. Because why make it any more confusing? So, Aryan, every time, right? Every time a sensor says, okay, I can send you maximum 10 readings in a minute. Okay, that's great. I'm getting 10 readings in a minute. But how fast is that one reading being sent, right? So, let's say for each reading, it's sending me 20 bits, right? How fast am I receiving that one bit, right? What's the speed of that one bit? Is baud rate. But it is, the baud rate is not really speed as much, it's a ratio, right? For every bit sent and received. Which is why both the controllers, both the sensor chip and the listener chip should be on the same baud rate. They need to know what happens if you change the baud rate. Let me show you what happens when you change the baud rate, right? So I'm going to stop simulation and let's make this 115200. Okay, in case you all are wondering how I'm coming up with these numbers, these are pre-programmed numbers. Okay, I'm not just randomly coming up with numbers. These are numbers that you see in your Arduino serial monitor. So over here, oh wait, this serial monitor is automatically taking the baud rate, which is a little sad. It's very smart but sad, because what happens is you can actually set the baud rate here. Let me see if I can quickly open my Arduino IDE and show it to you. Oh, okay, I'm going to show you where you select the baud rate, so you all know that these are not, random numbers that I'm picking. But that's how it works. Okay, so I can't control the baud rate of the serial monitor, which means that if I do start simulation, it will just become faster. Give me 1 second, folks. I'm just opening opening my Arduino. But yeah, you all get the point, right? So if this is at 115.115.200 and if this is at 9600, what this will show you on the serial monitor is utter gibberish. It's gonna be like, okay, a question mark here, a random symbol here, a random character here. It won't know this, basic baud rate that it's coming at. It's BAUDRATE. Baud rate. Make sense, folks? It's the baud rate. Alright, folks, let's move on very quickly. Let's quickly map our code from potentiometer to the LED, and then we'll come back and revise some other quick other. So we've revised digital output now. So digital output is 0, 1, right? What we'll also do is we'll take a DMM and we'll quickly measure our 0 and 1 is also. Alright, and then we'll do an analog write. So we'll basically control a servo angle you based on the potentiometer, and we'll see how PWM works with the LED right now. All right. So, folks who are joining us for the first time today, we understood what was PWM. PWM is basically pulse width modulation. So your Arduino does not have a digital to analog converter. What it has is a PWM, right? What is the difference? Well, a digital to analog writer would be able to give you a certain number that you can write to your sensor actuator to, give a certain speed or control the brightness of the LED. What Arduino does is it has a pulse, what in which it basically shuts on the LED, turns on and shuts off the LED very quickly, and basically makes a square pulse that it kind of emulates the number that you want it to emulate, right? So let's quickly have a look at how that would work as well. All right, so now we have a potentiometer here. Next, what we're going to do is we're going to map it, right? So we're going to map, okay, we're going to have another integer, which is int LED PWM. Let me stop the simulation in 1 second. There we go. Int LED PWM equal to 0. And what we're going to do here is LED PWM is equal to map. Okay, so what mapping is doing is basically it's taking one range and mapping it to the other range quite literally, right? So let's say you have one sensor giving you value 0 to 5, and you have on the other hand your servo which is 0 to 180 degree. What it will basically do is it will basically map 0 to 0 and 5 to 180, and it will basically, once you turn the knob, it's gonna give that value to the final thing. Over here our PWM is 255, right? So we're gonna use that to map our 0 to 1024, 0 to 1023 to 0 to 255. Make sense? That is exactly what we're doing. This is a potentiometer, which is basically a variable resistor. Make sense, Praful? Right? So I'm going to make this the lowest I can. Oh, this is still not simulating. So let's go back to code. Right? We're mapping it. So we're going to map. What are we mapping LED PWM to? We're mapping it to our potentiometer. Right? So potentiometer. Right? Then it's 0 to 0. And then it's 1023 to 255. I think the other way around. Let's see. 255 to 1023. Now, what I'm next going to do is I'm going to write this brightness onto my LED. So finally, what I'm going to do, I'm going to write analog, right? And I'm going to give the PWM. What's my PWM? That's the LED PWM value, right? But just to be sure what my value is here, I'm going to also print it. So serial dot print line, and over here we're going to go LED PWM. All right, maybe a semicolon, and we're good to go. Let's start the simulation. Oh, my bad. I did not specify the pin number. So the pin number over here is 7. There we go. And that should work. So the syntax for that is pin number and the value you want to write to the pin number, right? Like we did here. So we did a digital write, pin number 7, and we wrote a high. Alright, there we go. Let's start simulation now. Still not sure. Oh my bad, spelling mistake. Oh, alright. Now let's look at a serial monitor. It's 254. That means it's been mapped wrong. It's mapped. It's still 254, which means we're gonna switch it here. So it's gonna be 1023 02 stop simulation. So 0 to 255 will be mapped to 0 to 1023. Let's see if this works. And we need it the other way around. We did map it. 1023 to 255. And question. Still a bit much. So 0 0. Okay, worst case, I'm quickly gonna look up. Uh, there we go. There's something wrong here. Let me quickly look up the mapping syntax. Arduino. And this is map value. Original min, original max. So that should be 0, 1, 0, 2, 3. That's original min and max. And the next is, this didn't work though. I know for a fact, but let's see. Yep, this is correct. Alright, so folks, that's the syntax. Alright. So that's the syntax. The syntax is LED PWM, which is the brightness that we want for the LED, written on to map to the potentiometer. The original is 0 to 1023, which we want mapped to 0 to 255. Now let's see if the brightness of the LED is actually changing. Right, so let's see. Yep, you can see the LED brightness also, basically getting slower. But remember, it's a pulse width modulation, so you can see it blinking rather than, oh no, that's not why it's doing that. It's because the digital light is over here still active, so we're going to remove that so it's not a blinking effect. And let's just comment this out. And then we start the simulation. Now it won't blink. It will stay at the original. So it's turned off now. Over here it should be a little bright. It's gonna cross the threshold. You can see it's slightly bright and then it'll go brighter. So okay, there's something wrong. The brightness should change here. 137, but it also explains to you what I said about digital right? So anything below the half of it, it's not turning on, and anything above it, it is. But that's not how it's supposed to be. Let us reduce or rather increase the resistance here, and then we can go. Alright, so ideally it should have changed the brightness. It's not changing the brightness very obviously. But you can see that at halfway point it's turning on, which means that the PWM is increasing, but not as slowly as the brightness would ideally. Alright, so that's your analog, right? And your digital, basically, your ADC that we studied yesterday. Alright, folks. Awesome. Can you all, I'm going to quickly copy paste the snippet, code snippet for you all here. Alright, so, okay, and that's here. If you all want me to paste it in some other format, let me know. All right, we're gonna give you all like 4 minutes to follow. All right, so it is 4:44 in my clock. So around 4:48, I'm gonna check back in. Until then, feel free to ask me questions. I will answer whenever. And I'm also going to look into why this, potentiometer is not changing the brightness, but it's giving a basically digital high and low, which is not okay. Or we'll change the LEDs, specifications. Let's go for white. No, let's go for red. That's my question. Let me see if I can connect another component. So y'all can keep following. The rest of it remains the same. I'm just gonna try and change the component for. Hmm, Let me see. What do you all want me to put? Do you all want me to put this as well? Let me see if what you all are saying works. Okay, so you all are telling me put in three backticks, C plus plus. I don't think. Let me see. It's backticks, right? Uh, okay, let me try again. So CPP. I know that works in Discord. What you all are telling me to do. No, I know what you mean, Krish. Don't worry. I just wanted to see if it's actually, Oh, you wanted it in Discord. Yeah, I know that thing works in Discord. I thought you all also think it works in StreamYard, which is I was very surprised. And there you go. Alright, there you go, folks. I have. Oh, you all did put the LED. Kunal did. That's awesome. And Shimari also posted an IoT device. That's awesome, folks. I did not see you all posting the pictures there. Alright. There you go, folks. I will delete this message in a bit, but y'all can. I've pasted it there. Yeah, I thought y'all said StreamYard also works, which is I was very happy and surprised at the same time. Because if I don't know if y'all know, but if y'all post links to me, I can't click on the links from as a host. I only can show it on the screen. But awesome, folks. So while y'all do that, let me know when y'all are done with it. Let me and until then, what I'm gonna do is I'm going to quickly see if there's another component I can use to show y'all better the change in analog values that's happening. So let's take a DC motor. So if it's a motor, it does not really have polarity, so I don't really have to care about where I'm connecting the terminals to. The only thing that'll change if, let's say, I switch the positions again, so I reverse it, this direction of the, okay, let's see. Let's look at serial monitor. It has certain RPM. Is the RPM increasing? Nope. Okay, I'm gonna reduce the resistance of this thing and see if that works. Hmm. Just still doing the same thing where it goes halfway and starts, which is basically a digital 0 and 1. I don't know. I honestly don't even understand why it's going so wrong. Because there's absolutely no difference in the in the later potentiometer state also. So, acceleration. That's weird. That's okay. I'll look into it in a bit. Let me know if you all are done with this until then. I don't mind hosting the dev post office as but I don't have any hackathons scheduled until if we're basically August, so not until September, maybe. Uh, Actually, Shamari, I don't. The thing is, this is more to get y'all the hang of electronics. If y'all are doing it in person, the problems that come are so different. For example, like things half the time don't work because of loose connections. Like 100% honest there, like it's not even the code, it's never the okay, maybe it's logically wrong, it's almost always the wires that are messing up. So it's better to do it with the direct thing, because the problems that if you run it on Tinker and you're like, okay, yeah, this is amazing, it's better to just do it in, like, with the device itself. Is it your birthday crash on September 30th? Is that why you're asking me? Oh, I'll explain the code to you in just 1 second. I'm so glad you asked. Let me see. Give me comment based on this one, not bad, not this one. Okay. I am honestly not sure about an FPGA because I know that FPGA has a very different kind of coding, the branch. I'm sorry, I missed your question earlier. So, I'm honestly not sure about FPGA, but I can look into it. This is very simple. You understand this is not even something that is used for like industries, right? Arduino IDE is more for hobbyists and makers, but that's how you get started, right? In engineering, even if you're going to start with it, people are going to make you start with Arduino, get you with the hang of how things work, and then you go through the abstracted layers of what happened. All right, folks, my Arduino just might open at some point, so I can share that with you all. Okay, Alan, give me 1 minute. I'm going to quickly explain the code to you. But it is 55 on the clock. Are we all on the same page? Have you all at least connected the circuit? And hopefully your code works better. Awesome. Is your brightness changing or is yours brightness also not changing? Because I have a feeling I'm making some stupid mistake. The Tinkercad software can't be so wrong. But that is why explaining the code will help me also. Not changing? Alright, let's look at the code. We might figure out what we've done right or wrong. Okay, folks. So my screen is still shared. I'm still here. Let me increase the size a little more while I'm explaining. Alright, folks. So this I'm gonna close the serial monitor for a second. Okay. Cool. So this is where our code starts. We initialized potentiometer to 0 and the LED PWM to 0. Then we have our serial dot begin, which is at 9600. That's the baud rate. It's only used for serial printing, nothing else. So you don't have to worry about it at all. Our pin mode 7 is set to output, which is great. And then our pin mode, which is A0, which is our analog read for the potentiometer, is set to input. Amazing. Right? Then we have a delay. We can actually get rid of the delay because we're not using it right now. And then we can go on to our delay over here as well and maybe reduce it really. We don't need to delete it altogether. Alright, great. Then we have our potentiometer, which is our analog DTA 0. Then we're taking LED PWM and mapping it to the potentiometer value that we're getting. So we're mapping 0 to 1023 to 0 to 255. Then we're doing a serial dot print line for LED PWM just to see if our value was right or not. And then we're analog writing seventh pin with LED PWM, which is basically the brightness of the LED that we're changing. Then we have serial dot print line potentiometer, and then we have a delay. So our code's fine, really. I honestly don't understand what could be going wrong. So here's what I'm going to do. I'm going to try and increase the, let's do this one. Um, Start simulation, stop simulation, 7. Okay, folks. I told you I'm doing something stupid. I knew we were doing something stupid. Remember the reason why we connected to pin 7 yesterday? I told you specifically to connect to pin 7 because see what was happening every time the PWM crossed halfway through, it basically started giving it a digital 0 or a digital 1. To connect or to give a PWM, we need to connect it to one of these tilde pins, right? Because remember, the tilde pins are the PWM pins. So I'm going to quickly pick it up, connect it to 10, and connect this to ground. Go to my code, change this output to 7 to 10, right over here again to the pin number 10. And now we're going to see the brightness change. And I'm probably also, change the resistance of the potentiometer back to what it was. That is around 10 kilo ohms should be good. Cool. Let's start simulation. Oh my god. I told you, I just knew how you were doing something like there we go. See the brightness change. And you'll see a very significant difference. There we go. You can see it changing so obviously now. Yay! So you cannot do 0 to 512 because the PWM device on your Arduino is an 8-bit device. So what's 2 to the power with 8? It's 256, which is how you get values 0 to 255. However, if you end up using a different board in the future which has a higher magnitude of the DAC or DAC equivalent, you can have a wider range to address it. Had our output also been a 10-bit output, then we would have not had to map at all. We could have just given the analog read value to the analog write value, and it would have worked. Makes sense, Shimari? How do you find out what is the magnitude of your ADC or DAC? You read it in the data sheet. We'll look into the data sheet in a bit. Make sense? Awesome. Yes, Aryan, I will. See, so what we did was, you see, we had connected it to the digital pin 7, right? But remember, digital pin 7 is only a digital pin, which is why it was only giving a 0 and a 1. So every time the PWM crossed the halfway mark, remember, digital was, we divide the voltage by half, and as soon as we cross the halfway mark, it becomes digital 1, and just below its digital 0. That's exactly what was happening, right? So as soon as the potentiometer crossed, 157, 160, it gave you a bright LED and it didn't change the brightness. However, if you connect it to a PWM pin, which is giving you the pulse width modulation output, which we connected to here to pin number 10, we are getting the brightness change that we want. See, it's a very brightly lit LED, and you can see it change as we go. See, it's so obviously changing its brightness. Oh my god. I was so confused. I was like, what could possibly be going wrong? Code may you only changed the number that you're, so pin mode, instead of 7 you replaced 10, and analog right also you changed it to 10. Now if you all wanted to make it simpler, you all can also have an integer here. Stop simulation, right? So let's do a stop simulation. So int led pin equal to 10, and what you all can do is, over here everywhere just have the LED pin. So let's say next time you want to change the pin digit again, or the pin number again, you just have to change it at the top. So LED pin and LED pin. Next time, let's say there are multiple LED pins that are being changed, you just change the pin number at the top and everything in the code changes. What changed to red? Are you talking about the LED color? I changed it because I actually thought the LED color could be making a difference in us not being able to see the brightness. I was fairly desperate to get it working, yes. There you go. Yellow works as well. Make sense? Yay! It's working for you too, Roshan. But I'm glad this happened. Now you'll understand how much of a difference. You know how digital pin works also. The graph that I showed you all can now actually imagine it happening. Next time I might do this on purpose, connect it to a digital pin and show them how, the halfway marks work. Yay! Yes, everyone's happy. Let's So while we're all happy with this working, we're gonna take a quick breather of 5 minutes here, and then we'll come back and then we'll go over any concepts that you haven't understood. For example, I know Adi Snippet or Aryan, one of them wanted me to go over the ADC concept again. So we'll do that. We'll quickly go over a data sheet, see how it's different. Look at the chip, this chip, the Atmega 328P chips data sheet, where I'll show you, where the 8-bit ADC, 10-bit ADC, and the 8-bit output pins have been mentioned and specified, and how you all can later use the same thing to find anything about any chip in the coming whenever you make a project. Basically, I'm so happy right now, I really don't want to think. So let's take a quick 5-minute break. I'm gonna go out the screen, I'm around, I might just go get some water for myself. But yeah, you all go ahead, post your working GIFs or pictures in Discord, and I'll be back in just 5. It's 5:02 in my clock. I'll be back by 5ish, by 7ish. I'm still watching the chat. I'll still keep answering the chat. Okay? Yay, dance break it is. Oh, if you all are dancing, post a picture of that as well. All right, folks. We'll resume in a few minutes. right, folks. How's it going? How was the dance break? Do I have y'all posted your pictures in Discord yet? Oh, y'all did. That is amazing. I absolutely love what y'all have been up to. Aryan posted, Kunal posted. Also, Aryan, I hope I explained the code well enough. You know what's happening. And I don't think are these snippets in the stream anymore. But do you want me to explain ADC again? Alright, I don't know if you all are in the chat right now. I'm going to wait for a few of you all to respond. Oh, there we go. Aribappa is still here. Aribappa, did you follow? Could you get your LED to change its brightness based on analog read and write? Sure, Roshan. I'll explain mapping in just a second. Shamari is here as well. Awesome. So I'm going to quickly explain mapping. And is there anything else? Anything else you all want me to explain? All right. So let's look at mapping, right? Okay. So you have a certain value that your controller is reading, right? Which is 0 to 1023. Now, while we know why the value is 1024 totally, we don't really care about it right now. That's the value you're getting, right? Now you can't manually control you can't limit that number, and your output that you want to write is only has a range from 0 to 255, right, which is an 8-bit output. So you have 256 values, which is 0 to 255. You cannot write the value 1023. If you do, nothing will happen. It's basically going to exceed it. But what will happen is you won't be able to control the range as much, right? So let's say at 0 and at the highest voltage, you want the 0 brightness and the highest brightness at 1023. If you write the values directly at 0 to 255, which is basically half the value of the actual voltage, your LED was going to exceed the brightness, so your range is going to go smaller. In mapping, you're saying okay, 0 to 0, but at 1023 the value should be 255. So imagine having a scale. Let me see if I have my Jamboard open and I can show you on it what's happening. But did it make sense until then, Roshan? So stop screen, present, share screen, tab. There you go. Right. So what's happening in mapping is, right, you have one scale which is 0 to 1023. Right. So these are total may 1024 values. Right. You are mapping it to a smaller scale, right, which is 0 to 255. So the map function, basically what it does is it divides this entire thing, right? So that for every I just realized I'm not sharing screen. My bad, folks. So what I was showing was this is your first scale, which is 0 to 1024. Sorry, 23, which is total 1024 values, right? What you're doing is you're scaling it down to match a range of 0 to 255 for a total value of 256 values. Make sense, Roshan? Does that help? So in the mapping function, what it's doing is it's basically making sure that for every level that you change here, it changes between 0 to 255 in the same proportion. Make sense? Perfect. Awesome. I'm so glad it makes sense now. Great. Any other question, folks? Anything else that we've discussed till now that you want to, go over again, or for me to, uh, iterate? Okay, so I really want to go over one data sheet with y'all so that it's much easier. So how do you choose components? How do you choose? Okay, how do you know what the power specifications are? There are a lot of times that controllers are, 5-volt controllers, but if you take an ESP32, its base voltage is 3.3. So a lot of times you need to be careful about what you're using. One of the times I remember I connected, so a Pi, right? If you take a Raspberry Pi, it has a 3.3 base voltage, and if you take any pin and give it a digital high, the highest voltage it will get is 3.3 volts. I connected a servo of 5 volts, and I wasn't sure why it wasn't working for a long time, until this was back in like my second year, when I realized that, oh, the servo needs 5 volts, it of course won't move and take the signal if it's less than 5 volts. So you need to be able to, look at data sheets and tell, okay, this component won't work with this. If I have to make this work, you're gonna have to give it external voltage and make sure that is when your common grounding concepts comes into, picture, where you want all the grounds to be common, so that you can give it external voltage and make sure that the voltage is correct and it has enough power to run, basically. Make sense? All right, so I want to do that, one. And two, I really want to get you all started with WorkMe, because our final project, or the final design thinking and project we'll do is tomorrow, is on WorkMe. Why WorkMe and why not Tinkercad? Because over here in Tinkercad, there's only Microbit, which is capable of doing some form of wireless communication. I will look into it. I want you all to be comfortable with both the platforms, but WorkMe has a lot more features in terms of, it can also give it virtual Wi-Fi. So it helps a lot. You can connect it to Firebase, and we can see an entire cycle of, we can have two different codes running, one, code sending it and the other turning on the LED. So we'll do a simple IoT project, and yeah, you all would have done your first IoT project. So I'm excited. I hope you all are too. So let's tell me what you all want to do next. Do you all want to start with WorkMe, or do you want to go over a data sheet first? Any preferences? We have another 15 minutes or so. We started a tad bit late, but we can do for another 15-20 minutes for sure. So data sheet, Aryan says data sheet, Roshan says data sheet. So let's start with the data sheet. We'll give a vague you know introduction today. If you all don't understand it, we'll go over it again. Okay? Cool. So I'm just gonna open a new tab first and then share my screen. So how do you look for a data sheet? Right. And this is something, if you all have attended any of my previous streams on any topic that I do, I always stress on this, right? Let's say tomorrow in the stream I go on a monologue about some project and the number of components I, you know, call or talk about. Here's the thing: if you'll ask me what the component is, or what do I mean by that component, I'm only going to ask you to do one thing, right? This is what I'm going to ask you to do, right? So I'm going to ask you to tell me what component you heard. So component data sheet, right? It doesn't matter. It doesn't matter what the component is, whether or not it's a component you've heard of. If there's any question you have about a component, I'll definitely, the first thing, even if I know the answer, I'm going to ask you all to look up the data sheet. All right. So what are we looking up right now? You all can search for Arduino's data sheet. All right. But it's not Arduino that we really want, right? It's the Atmega 328P microcontroller chip that we want to look into. So that's what I'm going to look for, right? Atmega 328P data sheet. All right, so you can see there are a lot of data sheets available, right? Preferably, never go to all data sheet. If you ask me why, well, my mentor's been telling me that, and I follow the instruction pretty well. If sometimes like it's a Chinese component and there's absolutely no way of getting it anywhere else, have a look at it, but avoid it. Usually, you want to go to the original manufacturer, which is over here, Microchip. So there you go. It's a nice microcontroller data sheet. It's going to be a pretty big document, to be fair. There we go. Right? So you can see it's a 294-page document. How do we feel about going over 294 pages together, folks? I'm guessing not very happy about it, right? But that's okay. We will go over some of the basic things. Like for example, I told you over here we have an 8 channel, 10-bit ADC. That's what matters here. The 10-bit ADP, six PWM channels, and 8-bit counters. That is how we know that we can give a pulse width of 8-bit, right? Because our timer is so, and we're using the timer to basically turn it on and off, uh, to give it the emulation of the PWM, right? Awesome, folks. That is the basic stuff. Honestly, when you're looking at a data sheet for the first time, yes, seriously, it's 294 pages, Shamari. If you're looking for at a data sheet for the first time, there's a lot of things you can skip over, right? I'd suggest going over some of the things. For example, this is important, the memory, because remember another constraint that you have when you're working with embedded systems is you don't have memory like GPOS, right? You cannot just keep dumping code and saving stuff until you run out of hard drive. You need to be able to make your code so optimized that it also fits your microcontroller while doing a lot of complicated things. Again, the more features the controller has, ideally it also has as much memory to, they expect you to do a lot of things in the code. But that's something to know, right? So we have 1 kilobyte of EEPROM, 2 kilobytes of SRAM. This is what we run out of the most. Also, if you all ever want to run ML or edge models on IoT, the most important thing is SRAM. So if you go to Edge Impulse is one of the most amazing uh, ML for IoT companies. So it has a nice dashboard. If you all want, we'll go over it tomorrow. But they have a requirement, right? So they'll tell us that okay, this is the memory requirement. If this is your controller requirement, yes, you can run a machine learning model on it. And they have a requirement of the SRAM being 64 kilobytes. So obviously Uno can't run a ML model right now. Later on, in a few years, if we optimize it more, maybe someday Uno might run a ML model. Alright, folks. So we have write erase cycle. That means you can, reuse the EEPROM 10,000 times, and the EEPROM 100,000 times. So the flash 10,000 times and the EEPROM 100,000 times. Alright, great. So these are just some things to keep in mind, because these are the constraints you'll see for different, if you want to integrate it with different things. Yes, I do. I do go on a monologue a lot of times, which is why I need to keep checking in to check if everyone's on the same page. You know what, Divyansh? I would like to see you do that. So here's what I've been doing recently. If I can't see if I actually do this, I actually listen to a data sheet or something, and it's great because you're passively learning a lot of things. But I would like to see you survive 294 pages worth of data sheet being read out to you, because this is the first page. Wait till we go on to the next page. This is hardware architecture. So now as we move on, so again, these are some important things to know. SPI, UART, these are your machine communication channels. So so let's say tomorrow you have a sensor that you want to connect over SPI. How many SPI channels does your interface does your controller have? That'll decide your entire structure, right? Okay, so you have 23 programmable IO lines. IO lines are basically those pins that we are programming. And then this is the package name. What do you mean by a package name? So you remember in Tinkercad, it was a straight package. It has legs. So that package has a name. It's a double inline package, right? Like that, you have different packages. So for example, over here, we're looking at tinier package, right? So this is like a flat, tiny. It will be like this big. And it looks much neater than the big chip that we saw, right? Awesome. So then you have VCC. Remember, we need to always consider and read about the voltage constraints. That's what you do. This entire thing is about the pin uh, structure of this. So in case you're designing your own board in Eagle or in any other simulator, this is the reference you'll use to connect to the right pins, right? Awesome. Then this is the block diagram. This is an AVR CPU. AVR is the device architecture we're working on right now. All right. So there are multiple device structures. ESP32 is an extensor architecture. The most common name that you must be hearing these days is ARM, right? So ARM is a completely different architecture. And again, based on the architecture, there are limits. The chips are ever evolving. People are designing new chips every day. And how do the chips evolve? They evolve based on their needs. Every time a company is like, okay, we have a very specific solution. We want to do it at absolute scale. They sit and design new chips. If that chip turns out to be, like, okay, maybe not this, and if there's a company that's saying, okay, maybe we need a new chip to do these all things, they'll release a chip and they'll make evaluation kits, give it to companies that might need chips for that reason. And that's how the entire industry works, right? Which is why there are so many evaluation kits out there. Every evaluation kit is there to, okay, we have a really cool chip, see if it works for you. It is based on risk, right? It's a reduced instruction computer set. It's always reduced instruction computer set for controllers, right? Awesome. Great. Let's move on. So we know that this architecture of Atmica is AVR. So Arduino initially was exclusively AVR. It has very recently, as recent as like 4 or 5 years ago, gone into the ARM side of things. All right. Then they have code examples, they have data retention, and they have extra resources. Because of course, a 294-page data sheet is not enough to really understand the extent of. So you want to read the voltage structure, just go with the ADC and PWM channels, how it works. Maybe look a little bit more into ADC. If you really want to read about tomorrow, look up ESP32 and read about ESP32 and ESP8266. Make sense, Aryan? So what you'll be doing is, I'll just go over this data sheet. You'll have to look up ESP32 data sheet, go over it, and look at WOKME and compare what all you need to know. Sounds good, Aryan? Alright, so about code examples, AVR core CPU. So this is again how it's working. This is the program counter. You can see what is connected to what. This is your data bus. Awesome. Again, so you see, this is the first reading you'll ever do. So if I'll tell you, right, for the all the internships that I did as an embedded systems engineer, we used to get random projects thrown at us, and we just spent hours reading the data sheet, getting things to work. Because right now, mostly projects you all are using or making, a ton of tutorials are available. But if it's an original problem that you're trying to solve in tiny niche, a lot of times you'll have to solve it from scratch. That means you'll have to integrate components that have not been integrated with other components before. That's when you'll be reading the data sheet down to the T, right? No, I don't, Divyansh. I haven't read a data sheet in a long time. I'm actually right now reading a data sheet for this project that I'll be making on this board. So this is the board I'll be working with right now. So this is the Renaissance solution board that I'm supposed to road test. So I'll be publishing an article on that soon. But yeah, that this data sheet is much longer than the one you're reading right now. So it's not been fun for me, to say the least. Okay, so then you can see that everything that you all are doing has a register. Every register has a bit. So you all are basically sending that entire code, that entire bit, to switch a register and hence tell the sensor or the controller to do something. So anytime there's a true debugging that's happening, like on the ground level of a hardware, you're really checking for registers and the bits on the register to see what is happening. All right, folks. So you can see there's register, there's a stack pointer. This is how you know what's happening. So this is how you get the first reading, by the way. You just scroll through, you just see what is mentioned, what the datasheet folks thought it was important to mention, right? And you keep going over it. So we're just gonna, we're gonna quickly see. Okay, they've given a very detailed, how to see whether your EEPROM is corrupted or not, how the IO memory works. Yeah, just a description. Again, this is kind of important if you're using this from scratch with a new software or a new component, or if you're writing a library for the first time, right? So basically, the library on the core hardware level is actually going and changing the bits on these registers. Okay, clock sources, ADC clock. So there we go. This is the ADC clock. This is what's kind of important. So you want to have a look at how the ADC clock is working, because your analog right, digital right, these are the signals which are mostly used, right? Even if you want to run a simple LED. Okay, so there's a crystal oscillator which is giving you a, which is helping you keep a track of time. Pulsing crystal oscillator. Okay, I know there's a couple of crystals on it. There's another low frequency crystal oscillator. There's an RC oscillator, internal oscillator. Timer counter. Timer counters are another pretty important things to have a look at, know what kind of counter bits are there, because again, if you're not doing slightly more sensitive stuff, being able to be accurate is a pretty important thing. Okay, then now again we're back to some more registers. These registers, okay, power management. Very important, right? Sleep modes, very important any device you all are using, because sleep modes will tell you, okay, if you're not using the device, how deep into power consumption mode it can go without having to restart to, come back to life, right? So your devices where you tap and they come back to life, or they go into power saving mode immediately, those are things that are basically part of the design process, where you see, okay, this can go into sleep mode, and so you can see in what mode it can do what all, right? There you go, power down mode, ADC noise reduction mode. So these are the different modes of an Atmega chip. Verify, reset sources, power on reset. These graphs, again, something you want to understand if you all are connecting components that are sensitive to power, right? Okay, cool. Overview, watchdog timer, something, not nothing you need to. So watchdog timer is basically literally a timer that keeps a watch on a particular pin. So it's like literally like keeping an eye on something based on time. Like a, it's just very cool. But I've never gotten the opportunity to use it properly in a professional setting, so I won't talk about it more. So this is the time control register. In the end, when you're controlling the watchdog timer, you're basically changing the different bits of the register. Okay, awesome. 49. Interrupts. Interrupts, very important. Can anyone tell me the importance of interrupts? So, an interrupt is basically when you get a signal and your controller does a task based on the detected signal, right? There's something called a hardware interrupt and there's something called a software interrupt. These interrupts basically help you write code on scheduling basis. So let's say there's a simple button, right? A button is basically an interrupt. When you press the button, something happens. Kind of. Not just on and off, but it can be anything. For example, one of the times we were doing this testing on a motor. So every time the motor moved, we wanted to count the pulses. So what we did is we attached the motor to an interrupt. So it moved, there was a pulse detected, and then the entire algorithm of counting the pulse started. Make sense? All right. I do not need you all to go into so much detail. I am waiting for the power specifications to show up really. But this is a beautiful data sheet, as you all can tell, right? It's been done so, this is actually the testing that the entire MCU has been put through. And, oh, where is the voltage? I think it must be in the end if they haven't given it till now. And then they have an index also, which is amazing. Power. There are some more diagrams for you for designers who are designing with this chip. Um, Cool. So yeah, I don't need you all to go into so much detail. You all can tell I've never read this data sheet completely myself. These are some amazing voltage graphs though that help you all visualize the extent of the environments that you all can use it in. Typical characteristics, panel characteristics. Okay. Cool. So that's it, folks. All I need you all to, basically have a little bit of a understanding of these things. So go over the ESP32 data sheet. It is also this long, if not more. Uh, It is. I promise you, if you're trying to just two, three projects with different chips, you'll love data sheets. You'll realize how data sheets make you so independent. Like, how CS may once you know data structures, it becomes easy to kind of, design stuff and come up with your own algorithms. It's similar in electronics. If you know how to read data sheets and you understand data sheets, I'm far off. Like my goal is to be able to understand data sheets much better, right? So, example, my mentors, they look at a data sheet, they're like, okay, this chip won't be able to do this. This will be able to do this. That's the kind of efficiency and proficiency you can have with a data sheet. But if you know how to read data sheets well, you can design anything. Like, you know what to look for in a chip, basically. Absolutely, Shamari. Let me see if I can find you some good resources and you can just work on it parallelly and keep asking me questions. If anyone watches streams from the middle, they'll just be confused, but that's the whole point to work through the confusion. Alright, folks, while we're not over time with this stream, I am over time in terms of time. We don't have any other stream after this, so I'm not worried. Do y'all have any other questions? Anything I can answer? Tomorrow, hopefully, I'll have my rim ready as well, so I might show that off for a bit. Awesome. Anytime. I would love, you know what, if next time, if you all have time or you have a market nearby that you all know of, and you all can basically get a chip or a microcontroller, let me know. We'll sit with it. And if you all are planning to get it, we can do another session. There are a lot of empty slots this GHW. So I can ask Mary to give me another one and you all can just work real time on it. You all can come and stream and work on it. You can do something as simple as blinking an LED on a real board. Yes, you'll also get a lot of sore throat with me after that. I am an EE grad. I really would have been a better EE grad, but I'm not a very good EE grad. You're a high school student, Aryan. I am so proud of you to be, trudging through this. Don't give up. Okay, I know there are a lot of words. Trust me, it's okay. You're doing really well for how less you think you know. I know you know much more. And then remember we did the intuitive exercise. Always do that with yourself before you're starting something like that. Because you already have a general idea of everything that's happening, trust me. Oh yeah, that's a great. That's what I should have ideally said. Yes, participate in the MongoDB challenge next time, folks. Y'all can win yourself IoT kits. Krish is also a high school student, by the way, Aryan. Yes, he's been doing an internship for a year also. Alright, folks, I'm going to close the stream now. Thank you so much for sticking around till the end and being interactive. I really appreciate each one of you. And I shall see you tomorrow. We don't really have a plan yet. All I know is we're going to start with Hopefully. I want everyone to get started with Hopefully, and we'll try and create a simple, IoT where you send a command, it goes over the cloud. We might use Firebase, and we'll basically make an LED beam. That is it. That is it. I'll try and figure out some basics for y'all. And if y'all are planning to get boards, do give me a heads up. I'm happy to schedule another stream by Monday, specifically for IoT. I do have streams on Monday and Tuesdays, Sunday and Monday for different topics of technical topics. All right, folks. I'm gonna close the stream now. I shall see you tomorrow. Bye bye.